Okay, hi, welcome to this talk about Kotlin versus Java, or Java versus Kotlin, or whatever. It will be a battle. We have the blue corner, we have the red corner, and each of us will be taking our stance into, well, let's say our favorite language, right?
Yes.
And we will be battling out this language. We will try to find out which one is the best. But it's not up to us. We need your help. First of all, I want to see what my pace over here is now. Who of you is a Java developer? Some pretty vibrant, enthusiastic Java developers over there, because they probably want Paulien to me to win, so she will tackle me on stage or something like that. Anyway, who is a Kotlin developer? Okay, who is on Java and wants to actually be a Kotlin developer?
Yeah. You see?
Oh, some people actually want that. There are stranger things in this world, however. But so we're gonna battle out, and we're gonna enlighten both the Kotlin and the Java part in 6 different rounds. All these rounds will be, for instance, I will start the first round. I will put a statement up. I will give you some examples, and then Paulien will counter that. At that point, the next round she will start. And I will counter that. And so we go on and on for 6 rounds. And after that, we want to see how many of you are in favor of Java or in Kotlin. So we already saw how many people are using it. How many people are more in favor of Java? 3. Awesome. How many people are more in favor of Kotlin?
That's a lot more, Brian.
That's 4. That's 4. Come on. I can change that. So let us first introduce ourselves. I think that will be the best thing. So
yes,
that's you.
Well, that's me exactly. I'm Paulien van Alst. I'm a software engineer at Open Value, and I really like to speak about Kotlin. But I'm also widely interested in a lot of other stuff of software engineering. That's about it.
That was short.
That was short.
It's like Kotlin, right? Short.
Yeah, it's really short. Less is more.
Okay, my name is Brian. I'm a developer advocate for a company called Sneak. Normally, we do something with security, but this time, I'm going to cover the Java part. Because, actually, it's funny. My mother is Indonesian, and guess what? She was born on Bandung, one of the major cities of Java. So I can actually say Java's in my blood. Which is cheeky, but it's true. So, between us and the pub quiz and beers is this battle talk. So I hope you will enjoy it. Let's start with the first round, shall we?
Yes, let's go.
All right, I'm up. First round. Who knows what the word YAML stands for? Yet another markup language, right? And, well, if I look at Kotlin, I see yet another language, basically. There is, again, another language on the JVM. Oh, wow, it's the new hype train. Let's get on that. But we've seen this before, didn't we? We've used Scala. We've used Groovy. And I actually saw companies moving to Groovy, from Groovy to Scala, from Scala back to Java. Who is using, I know there are a few because they're in the front row, but who is using Groovy at this moment and on his production systems? And I'm not talking about Gradle. I'm talking about Groovy as your main language. 0. Who is using Scala? 5. Awesome. That's the whole point I want to take, because the JVM language was originally designed for Java, and then a lot of other languages could come on that, and they might have great ideas. They might have great implementations, but at the end, you see that people move away from a job, and we turn back into Java. So why should this be different from Kotlin? I mean, I know this is a very, 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 very big slide with a lot of information on that. If we look at the top 2 languages in 2019, it's JavaScript and Java. And then Python, PHP, C#, C++. Is CSS a language? Fair enough. Kotlin is on the bottom. So why should we invest time in Kotlin? I'm not arguing if it's better or not, but time. Because if I'm a company owner, I'm a project owner, and I want new people in it, what would be the chance to get Java developers versus Kotlin developers? I mean, if we look at people that are just coming out of their university or something, what would be the biggest chance of getting a job? Well, JavaScript was one, but Java, Python. Why invest your time in Kotlin? I mean, if we want to learn another language, which is fair because you need to broaden your perspective, but should you focus on Kotlin? Because doesn't it do the same? If you look at the JVM report 2018, and the 2019 report is coming out really, really, really soon. I'm actually writing it. And no, I'm not mixing up the numbers. But you see 90% of the JVM users are using Java. There are more Clojure users than Kotlin users. So should we invest highly in Kotlin? Why not do other things? I mean, first of all, I want to make sure that there is some kind of continuity in our projects. If somebody drops out because they move jobs, it's easier to find a Java developer than a Kotlin developer. Because we saw it was 90% versus 2 point what? And again, let's be honest. Kotlin is nothing more than syntactic sugar. And it compiles back to Java 8 bytecode. So think of yourself, are you using Kotlin because of the new functions, or are you just afraid to upgrade Java? I mean, who have used on Java 8? Who have used on Java 11? Just prove my point. So again, why Kotlin? That's the first question I want to ask. If you want to learn new languages and you want to go into the functional spectrum, why not go for Lisp or Haskell to broaden your view? If you want to go learn other perspectives, why not go into things like Go or something else in the JVM just to broaden your perspective, which sincerely is a good thing to do. But why Kotlin? Why?
Why? Yeah, that's a good question. You're right on the part that a lot of people are still sticking to Java, but that will definitely change. Because Kotlin is not just another JVM language. It has been developed by developers for the developers. And that's maybe a bit cliche, but that means that when you start to learn Kotlin, you will see that the learning curve is very smooth. You can learn it pretty quickly. And it feels really natural to write it, actually. It's the best of all worlds as well. People who develop Kotlin are not dumb. They have seen Scala and Groovy as well. Brian. They have worked with it as well, I think, because they actually base Kotlin on all the other ones. They've looked at these languages and seen what was good and what could be improved. So they also learned from the mistakes from the others. So where Groovy's typing system is a big challenge when you're programming, Kotlin will solve that for you. It's properly typed, for instance. And as of 2017, it's the official Android language, which means that actually big companies are seeing potential into Kotlin. If I'm saying Kotlin, most people will think about Android application because of that. But actually, out of JetBrains' own survey, which was filled in by the Kotlin developers themselves, was shown that more and more people are using Kotlin to do backend development. So it's not a language for only mobile applications. It's also coming back into the web backend parts. But also, bigger frameworks and bigger companies are using it as well, which proves that Kotlin is getting more and more into the field. So some big frameworks, such as Spring and Gradle, which are pretty big in the field, are supporting Kotlin more and more. Vertex as well. So that proves that Kotlin has a lot of feature to work with, and that the interoperability with those big frameworks that we are using will smoothen up. Big companies as well. JetBrains, of course, use it. I mean, they developed it. If they wouldn't use it, that would be a frightening fact, but they use it as well. Coursera and Netflix, but also Uber and other big companies are using it as well. If they believe in it, those big software companies, I have the feeling I can believe in it as well. So, yes, it's another language, but it's a language that's going to win. Second round, less is more. My introduction was short. My coding will be short and efficient as well. Take, for instance, this class declaration in Kotlin. This is just the equivalent of a plain Java object, well, in Java. If I'm thinking about an object, I want to think about the name, but also directly about the constructor. In Kotlin, I'm enabled to do that because I can just write it down in one line. I declare my class, board game here, all together with its member variables here in the constructor. That makes it very easy to read. I know in one blink of an eye what the class consists of. So it's easy to write and it's easy to read. Using the data keyword, I can also specify that this is a data class, of course. That means that it will have getters for the variables, but also setters if needed. To string method, a copy method, hashcode method. So I'm safe with that. Equals method for sure. And that with all the help of no third-party libraries. That means that not only this is much more efficient and it's baked into the language, it's also less maintenance because I don't need to maintain a third-party library such as Lombok, for instance. So that brings safety along with me, but also less work. Another thing, Java has it since Java 11, but Kotlin has it since the start. I can use type inference. So for instance, when I declare this variable as a string, I don't need to specify it's a string. You see it right away. Another thing, this variable is immutable. That's why it's using the keyword val. If I want to achieve that in Java 11, I need to define it final and then use the keyword var, and then I have my immutable variable. Same with the constructor methods in Kotlin. They're much easier to work with. I can use listof and mapoff to construct my list and maps. Where in Java, the order of my map declaration will define if a value is a key or a value. In Kotlin, I can use the keyword to. That makes it much more explicit. It's easier to write, but also, again, easier to read. So that will be the Java equivalent. In Java 8 is an example, for instance, but in Java 11 doesn't change that much. And last but not least, this is a very important one. Also, it's very small, although it is very small. No terminator operator. The semicolon that you sometimes seem to forget, and then you're debugging all along, or it's not compiling, you don't understand why. You can leave that behind. That's the biggest boilerplate code that we have. I stated a few times, but code should be efficient to write. We're most of the time writing it once or twice, but it should be much more efficient to read. And you will achieve that with Kotlin. Less is more. Really?
Yeah, I think it's Java? So cute that you just point me to the age of 30. Thank you. But less is more. Yeah, less is more. That's what I said to my manager when he said you need to write documentation. No, less is more, right? But again, I mean, less is more. Fair enough. But how do we write programs? First of all, you write programs in an IDE. Who uses VI as your IDE? You're diehard, sir. There's one person sending us out, I'm using VI. But again, what do you do if you write Kotlin and you want to write a main function? You write main tap. And that it does function main in Kotlin. What do you do in Java? Public static void main, is so PSVM tap. Oh, 4 letters. And again, 4 letters. So it's easy to write is not a statement. We're using the IDE either way. You're not using Kotlin from your notepad or your VI. So easier to write, fair enough. But that easier to read, I understand. But first of all, we have to think, what should we actually do with our objects? Because data objects give you all this stuff for free, but do you actually need it? That's a fair question, because that's also the thing that people say with Lombok, for instance. Yeah, just put the data annotation on it and we're done. But isn't that the same thing? I mean, shouldn't we only create what we need? And if we talk about boilerplate code and we say, oh, wow, we need to implement 2N annotations in Lombok to do this. First of all, if you write it down and if you use your IDE to do it, you'd make it explicit and you see if people actually need stuff like getters, setters, whatever. If you don't want to do it, we have these libraries to do so. And you're naming Spring yourself as a library. And that has like, how many annotations? So, and the other part is verbosity that bad? If you need to debug something, you probably want so much verbosity as possible because we want to pinpoint where the problem is. Is that the same thing with all the magic with Kotlin? So, for instance, we have this Java thing, and I use Lombok to create a toString because I need it. I use getters and I use the arc constructor because I do not need any setters. Fair enough, simple and concise. But if I want to, does it work? Yeah. But if I want to use DTO objects, data transfer objects, why not just use public fields? Think about it. We're so like, we feel that it's so painful to use public fields. Oh, public fields, oh, that's dirty. But why? We're setting stuff, we're getting stuff, it's a transfer object. Come on. So why not make it public so we don't need anything? Not even your generated data, getters, setters, whatever, rumble. Next one. We have this thing in Kotlin. It's a credit card, right? It's a data class. And it has a label, maybe my MasterCard. It has a name, it has a number, a name, a security code, and a data, or a date thing. There are two things here that you do not want to show. That is the number and the security code. But what happens most of the times? Oh, well, let's create a data class. Something went wrong. We throw an exception. Let's throw that in your log files. And it has the toString already. Now you have a GDPR issue. Good luck. Because it's true. You cannot just put that out because least privilege principle. So I need to rewrite my toString statement. I have to override it. Cool. So I can override it. And that's what I can do in Java as well. Guess what I can do in Lombok? Just put an excluded statement in it, done. So who is the less is more now? Right?
It's explicit.
It is explicit. It excludes something. It's very explicit. But again, okay. We want to write less. We want to write less because less is more. Java 9 has the off constructor for lists and for maps. So all the people on Java 8 just upgrade. 2017, right? September 2017. Java 10 has the var. You may like it, you may not like it, but if you want that less is more and you believe that baloney, just upgrade to Java 10. Done. Oh, wait. Java 9 and Java 10 were like non-LTS, 6 months. Java 11, September 2018. It's already out. So you have that stuff for free. Java 9, Java 10, and you have long-term support. And in Java 12 and Java 13, although it are still, how do you say that?
Preview features?
Yeah, but it's still possible to use them. And you know why they're preview features? Because they got feedback from the community, and the community said, well, we can do that better, so they moved it from 12 to 13 to improve it. And not just like, I am this big company, I rule. So it's a far more fair process. Less is more, maybe. But if you want less is more, just upgrade your Java version. Good luck. So I want to talk about something different, and that's how we're going to do round 3. And round 3 is about structure. And you can say from Java what you want, but it has structure. It is very, very much structured. And why do we want structure? Because we want readable code. Right? And readability makes sure that my code is clear, my code is organized, and my code is consistent. And that's what Java perfectly does. Because everything lives inside a class file. A class file may have fields, may have a constructor, and may have methods. So you know that a method is described on a class. A method cannot just be appearing out of the open. Like, oh, wait, let's extend something, or let's create something globally. No, we very much know that where it is, where it goes, And even for the people that work on VI, can knows that, okay, it works in the foo class and there is that method, and not like in some weird utility file deep down below that I just magically import. So structure. And, well, I'm a programmer. I'm a bit narrow-minded, perhaps, but I like structure. And what I want is, I don't write code for machines. I write code for people, and people need to know where the stuff is that I wrote. If I write a function or a method, then it's living inside a class, period. And if I want something else, choose another language. But do we want that? I want the things to be clear, concise, understandable, and making sure that the person that comes next to me, that when I leave the company, because I probably will, somewhere, can also understand it. So, talking about structure. This is possible in Kotlin. Wow, less is more, and very readable. I can match on Saturday and Sunday. I can match on a list. I can match on numbers, and makes these kind of things makes it more or less readable. And this to-do function or this do-foo function, where does this come from? In Java, you know that the do-foo function is, well, actually a part of the string, or else you cannot do this, right? In Kotlin, we can magically do some extension function in a library, import that somewhere, and now it's available to you. Good luck finding where your problem is. Oh yeah, you can use your IDE. But the point is that code readability should not depend heavily on IDE support. Why? What do we do when we check our code? Who does code reviews? Okay, the rest of you does pair programming? Okay, now let's keep it to that. But if you do code reviews, where do you do your code review in? You check it out, and most of the time you do that in, for instance, the diff of GitHub or the diff of Bitbucket or whatever system you use. So it's not your IDE, it just points out where the different lines are. And now it's like the do-foo. Where does that come from? I have no idea. So, what you got to say about that?
Well, that you should learn a lot about Kotlin, because that was not really nice Kotlin code I saw there. I can do very dirty stuff in Java as well, but I just don't do it because
you know where this example came from?
No, not from my code.
No, Venkat's book.
Ooh. Yes, to learn a lot as well. So, yes, I agree with you. Structure, indeed. Structure. Kotlin will help me with that. And it will help me a lot on parts that Java can't help me with it. For instance, in Kotlin, I can finally define several classes in the same Kotlin file. That means that when I'm describing my domain, which in this case is a person, which has an address, I can declare in the same file the person and the address and the zip code also belonging to that address. Of course, in Kotlin, or in Java, I'm sorry. In Java, I can do the same with an old package where we'll just group those three classes together. But at least in this case, I will have my three main domain classes all together where they belong. So if you're talking about code that is easily to read without using an IDE, well, here it is. I make it very explicit that those three classes belong together. So I guess Kotlin will help me with the structure indeed. The other thing is, all classes in Kotlin are final, so you can't extend them without doing any tricks. So it means that this parent class is not a parent class actually, it's final, I can't extend it. So here I'm safe. I defined the rules about this class in my code base. But if I want to extend it, I can actually declare a sealed class, which can be extended only in the context of the file. It makes it very safe and very secure. I can really tell the colleagues coming next to me on my job that, watch out, only extend this class in the scope of this file, and then you'll be safe. And if I really, really want to extend classes all over the place, like we do in Java, I can just open my class, make it explicit using the keyword open. So that will give me structure as well. I think I'm right. I think Kotlin is the better one.
That's what my wife said. I think I'm right.
Yeah.
And I keep it.
She probably is.
Yeah, well, fair enough. But let's do like every good match has like two halves, right?
Yeah. So we've been to the first half. Brian stating all those numbers to you, showing you nice reports that his home company wrote.
Somebody needs to do the heavy lifting.
I showed you some examples from the community, so I'm curious. Hands up for Kotlin. Ah, come on, people. I see a lot. I see a lot there. You might not see them. You're a bit older than me.
That's a dark.
There.
Hands up for Java. Thank you.
I think we're half.
Well, we're fair enough. We're halfway. We're halfway, right? So,
yeah.
Second half. Normally, I started the first half, so you can start the second half.
That's very gentle for me.
Go for it. Go for it.
Yeah. Ready to lose?
Hmm?
Ready to lose?
I'm in favor of it. The numbers are in favor.
Fourth round. Mr. Security. Safety first. Safety first. When we're coding, we need to protect ourselves from future mistakes, but also mistakes from our colleagues, right? Well, Kotlin will help us with that as well, of course. People, do we really need nil? How annoying is it to have a nil pointer exception in production? I feel really bad when it happens to me. It feels like going back to school or something. I feel really dumb. It means that I didn't really thought through my code. Take this class, for example, which has some value in it. And I want to access that value. But in the first example, it's nillable. That means it can take the value of nil. The second example, it doesn't. I want to access that value, which I set to nil, and then do a toString on it, because I want to. Well, it won't compile if the value is nillable. Kotlin won't compile that, because you haven't thought of your nil pointer handling. So I have to think about it as a developer. What should I do with it? I can place a question mark between it and it will compile, and the whole expression will evaluate to nil. So that's the end of the nil pointer exceptions, right? Okay, but as Java developers, we want to stay into our comfort zone. We don't want things to change. That's why we're still not upgrading to Java 11 somehow. So here in the field, we have nil pointer exception lovers, right? We really love them. We don't want to come out of our comfort zone. Well, it's possible. It's all fine. You just replace the question mark into two exclamation marks, and it will throw a Kotlin null pointer exception. It's not a mistake. It's not a typo. It's just a Kotlin null pointer exception. And then we'll be all happy again. We have our exceptions back. My whole point here is I like this feature because I have to think what to do with my nullable types. It makes it very safe. The other thing is that data class that I can do with Lombok, only implementing what I want and what I need, that's cool. But the data class is not valid in my eyes if it doesn't have a copy method, as we're working with immutable objects in Kotlin. If it doesn't have an equals, a toString, and a hashcode method, those are very important. You don't want to forget those, right? Otherwise your testing will be terrible or your if statements will be just falsy. You will have your getters you will have your getters as well, and your constructor will always be there. So you will always have to construct your class in a valid way. So that's very, very safe. If I'm using Lombok with his less is more argument, I can choose out of it and I can easily forget them, which makes it very unsafe. Yeah, curious to see what you have to say.
Yeah, this is the background of the Teletubbies. I'm just waiting for Tinky Winky comes over the hill. No, but honestly, tell me, who of you is working on a greenfield application? 7. So that means the rest of you probably needs to work on all applications, and we need to migrate and we need to maintain them, right? To be honest, I was working with a coworker, and he once had the phrase, "Greenfield applications are for pussies." For the sake, because a greenfield application, you can choose whatever you want on the right time and use the most perfect, most hyped framework now. But that's not the clue. Like 90%, maybe even more of our work needs to be done in applications that already exist. Even applications that already exist and still need to run while we're maintaining and adapting these applications with new features and whatever happens, what the product manager says, right? So, there are a few things that we need to consider. Who have heard of these kind of libraries? Who worked with these kind of libraries? Who love these? No, don't care. I don't care if you love them or not. But you need to work with them because legacy. Like if I was here at JFL like 12 years ago, it was like Hibernate is king. And now it's like Hibernate, but we need to work with them. That's a fact, right? So, safety first, right? What should I do first if I want to use these libraries in Kotlin? I introduce new dependencies because they don't work out of the box. And we need to maintain this stuff. I mean, I can't say, let's screw that over, let's start again, let's start over. Ask one of our main sponsors, Rabobank, if that's possible. Don't think so. But we have to introduce dependencies to make it work. And that was one thing you was like, okay, it's dependency free, we don't need all that stuff. Cool. Oh, wow. What do I need to do more? I need to use annotations. The ones you just hated because you didn't want to use Lombok. So now we're back at square one, using Kotlin, but I have to use GPA or Hibernate, and I still need to do this crappy stuff to maintain it. Is it worth it then? Is it still a thing? And I mean, let's be honest. That whole stateless thing is, from a safety point of view, in Kotlin, is true. I mean, if some things are stateless, it's predictable, and I get that. But what do we try to do in programming, in automation? We try to implement the real world, right? And let's be honest, things can change. I mean, I can also cut my hair or getting bald. I can paint my bike. States of an object can change. That's a fact. And we can say, well, let's not do that. But what do we introduce then? A pile of garbage. Because, well, more objects, more stuff, more garbage, garbage collector kicks in. Is that actually what we really want? So that safety and that, I get that null thing. I will give you that one. That null thing is, well, in Java is hideous. But the safety part, more and more in Kotlin, the Kotlin discussion goes about that statelessness and using values everywhere. Well, talk to people who need to write high-performant applications. Is it still doable, or do we need to be stateless? And where is that benefit then? Yeah, that's me. I'm lazy. That's true. That's not my cat, though. But let's talk about laziness. I mean, less is more, sounds good, but if I don't need to do it, I'm not gonna do it. That sounds even better, right? Why do stuff? Why not? Well, not needed. Well, let's get into laziness in Java. It's pretty obvious that who uses the Stream API? Almost everybody. Thanks. And the Stream API is a lazy API, right? Because we expect, if we have a list of names, and we do the two upper, and then we filter, and then we do it for each on that, each of the statements in that list go through that pipeline one by one. Because that seems natural. That's how we treated lists forever. That's how we do. That's how we work. Oh yeah, if you want to write it shorter, you can use var. Done. Less is more. Okay, now we have a thing in Kotlin, and this is hideous code. But it's just to prove a point. I have a list here in Kotlin, 1 to 6, and I map and I filter a certain function over it, and I do a side effect just to show you something. Because people say in Kotlin, oh yeah, the map and filter, that's cool, but you always need to do that .stream. And in Kotlin, that is not necessary anymore. We can do it directly on a list. The point is, it's different. Because what do you expect if you read this code? Normally, you would expect the 1 goes through, the 2 goes through, the 3 goes through, etc., until 6, right? This is the output. Which means that the whole list goes through the map first. Is in memory. somewhere allocated, probably on your heap. Then the whole list, which is there, goes through the filter. And then we're done. So it's not that easy. It's not that obvious. There is a subtle difference in it. Lists in Kotlin, so the dot map in general, is eager. We can solve that. But then we need to do a dot something. Hey, in Java, could you dot stream? I think it's less letters. It's 1, 2, 3, 4. Yep, less is more. So if we want to have the same behavior, we cannot just say dot map. We have to be sure that it is a sequence. And you need to be aware of that. And I'm asking you and the audience, do you think that is something that you thought of first? Do you think that is natural? Do you think that is the way you thought it would work? Probably not. And there is we can say it's by the way, this is the Java example for the same thing, and you see that it is lazy. And we can say, yeah, well, eventually we have the same thing, and memory is cheap, and who cares? Well, I do. I here do a sum of a list from 1 to 5 with many zeros. And I do that with a map on a list and a map on a sequence. So the eager one and the lazy one. And you probably see, well, there's a lot of numbers, but the map, the sum on the normal map takes about 14.7 seconds. The same operation or the same result for the sum on a sequence only takes me about 2 seconds. If we look at the average, it's 11.4 seconds versus 3.2 seconds. So you have to take care of what you are using. It may look simple, it may look obvious because, well, you need to write less and it seems more, but you need to be aware of what you do. Know your language.
Yes, you should. So, I will give you this point. I think a lot of people wouldn't have a thought about it, about this whole laziness evaluation. So for sure, in Kotlin we do have the choice. Do we want a lazy evaluation or not? This one won't be lazy, as you already said, but this one will be. But even better, I can just declare my lazy doors as just a sequence instead of doing this as sequence. It's just a proper collection in Kotlin. So as a developer, I need to think about what is this collection and what am I going to do with it. So it's a conscious choice, which in my opinion is actually very good to make, to be conscious about what you're doing when you're coding. Exactly. So this will be a sequence. You can just declare it like this. And yes, there's a bit more letters to type, but it will at least be explicit and clear. So I will give you the laziness point, but still, I think it's a good thing in Kotlin. Round 6, last but not least. Controlling behavior on collection level. When you're doing object-oriented programming, we're only talking about single person instead of people. Talking about a car and not about cars. Talking about cats, a cat and not about cats. Well, the world isn't made that way. Like you stated, we are modeling the entire world. We have a lot of people around here, we have a lot of cars around here, and I think also a lot of cats. So, for example, if I have this data class describing a cat, which has a property which will state if the cat is an adult or not, that's nice. I can look to one single cat and to say if it's adult or not. But in Kotlin, I can also use these terrible extension functions to define a method which will just describe which cats in a collections are adult. And this is proper programming, because here I'm describing the world, right? We have a lot of cats. We have a lot of cats where we want to know if they're adult or not, instead of having just one single one of them. The extension function that Brian just showed you, that's a bad example on how to use them. But again, we have a lot of tools. We can use them in a good way or in a bad way. This is the good way. This is a proper way to use them. And this is very important to all your filter, all your collection manipulations, so filters and maps and stuff like that. It's a good thing, in my opinion, to put them into an extension function so that you use that extension function everywhere where you need it, instead of duplicating your code and maybe make mistakes. Yeah, and you can actually call it like this. So that also reads very nicely. You can actually show that to your product owner, and he might, or he will be able to read it. Another thing is, which is completely mathematically correct, is operator overloading. So, for instance, I have a data class which is a money, which of course has an amount and a currency. And I want to add money in my application, which we do a lot. We have a lot of applications in this world manipulating money. I can just overload my plus operator and just tell, for example, that if I'm adding money of 2 different currencies, I will just throw an exception. And otherwise, I will just return the sum of the 2 amounts and the currency in a new instance, which is the sum of that. So if I could declare 10 euros and I want to add 2 euros to it, I can just write it down like this, 10 euros plus 2 euros. I don't need the IDE to understand that. When I'm doing a peer review, it's very clear. It's much nicer than having the same Java equivalent where I throw my exception in kind of the same way, but I'm using getters here, which already is boilerplate. And then I need to use this big decimal class, which is kind of nice in Java, but still I need to do a .add, which is obscuring the summation that I'm doing. At least to read this is much harder. And then I can finally return my new instance of the class. Another thing that's very important as well is that I can finally write my own DSL without, it's just very easy to do actually. I can write my own tests where, given my test scenario and these requirements, when Kotlin is better than Java, because it is, well then, Kotlin wins. This is proper Kotlin code. I can just, oh, I think something is going wrong with the slides here. Oh, yes, just going through it. Yeah, you see Kotlin is better than Java, and yeah, Kotlin wins again.
Oh, yeah, you do twice to make sure that people...
You're manipulating my slides, I think. What are you doing? Oh, yeah, there it goes. So, take for instance that my test scenario, which is in red over here, I can just declare it like this. Method, I think it's... I can just put my method into brackets, and then it will have a human-readable sentence. This is a nice language feature to use into your test code, where it can be very useful, and maybe not so much into your production code, but in test code it's very nice. I think it's going down. I'm sorry, the clicker is doing...
No, let's do it
yeah?
like this.
Can you do it like that? Thank you.
Oh, yeah, you got the end bar.
I have the end bar over there. Then I have my end keyword here. I also use that as a keyword. So I can declare that like this. It's an infix function where I can write down what that end word means. So I can completely describe my testing DSL. Yes. And there we go through it again. Sorry, guys. Kotlin wins again. And now the given method will be shown like this. It's very easy to write again. I can just describe this method which accepts a block and will return nothing. And this will be my testing scenario. So, yeah. Those are really useful features that I have in Kotlin. There you go.
What was your first argument? Less is more. And I see the slide 5 times. I know you want to say people, Kotlin wins, but repeating yourself 24 times doesn't help. I'm sorry.
If you need that to win.
But okay, fair enough. Behavior and that operator overloading. I get that part with the list. It's nice, it's funny, but we can write a library in Java for that, and it's perfectly fine. But that operator overloading. I have a Java example here, or a Kotlin example over here, sorry. And I have these two. I have my own object foo, which consists of a string A or B. What would A plus B? What would be your natural feeling? What would be your intuition if you connect A plus B? AABB or whatever? You probably don't know because it depends how it's implemented, right? That's the same as question because this is just an arbitrary object. But how do you connect a sheep and a goat if you connect that to each other? What is it? It's more funny to say it in Dutch. Schapen en geiten. What? Whatever. So you don't know. Basically, you don't know. And that's the whole reason why we cannot do that in Java. Because if you read the code, you have a certain understanding of what a plus sign means. That's the whole reason why you cannot override the binary operators plus times and that kind of stuff. Right? Because we need to read the code. Well, let's make it worse. Let's make it worse. Because I have this foo example, again, which is A and B, 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 B. But you see that red line? I implemented some funky util. Where is that plus overloading created? Is that part of the foo? No. So it's extended somewhere because that nice extension function, I thought you said something about safety. But with extension functions, I have the ability to extend a certain object with a function. And then because importing, I can do that in an arbitrary way. I can do that anywhere. That's not safe because you have no clue where it went. And if I read this code, I would say, okay, A plus B would be something like, I have absolutely no clue. I mean, is this programming language? Is this something I want to debug, or is this a guessing game? Because in this case, it gives me just the value funky. Because in my funky util, doesn't matter what comes in first, what comes in second, I just bind it to funky. And if you read that code and you are reviewing that code, you're like, okay, A plus B must be something like A, B, B, whatever. Cool, let's go on. Let's ship it to production because, well, we all have these managers there who once said, I want this function yesterday. Right? You recognize that, or do you have an easy manager in that case?
I have an easy one.
You have an easy one. Fair enough. Maybe I should work at your place in that case. So the point is, operator overloading can be nice, but Kotlin enables you with the extension functions and the operator overloading to do nasty stuff. And if we say we want to make it easier for developers, should we allow this in general? That's the last question. And that is actually also the last round. So now it is up to you. I mean, what do you think now of Kotlin? What do you think now of Java? Because we want to leave this room with only one winner. So, let's get to that final verdict. Ladies first.
Okay. Okay, who is ready to show their hands for Kotlin? Come on, guys. Come on, come on, come on. That's nice, right? That's half of the room.
That's half. Come on. I'm old, but I'm not blind. I mean, it's your own posse plus somebody you bribed, basically.
I've bribed no one.
Okay, who's in favor of Java?
You bribed them.
Definitely. Of course, I promised them beer. But we want to say we did the hands for Java, so I want to see them again. Hands for Java. Yeah, I love to celebrate my words. Hand for Kotlin.
Come on. Come on.
That's more. That's not fair.
Yeah, that's more, you see?
Anyway, we are pretty dogmatic in all these statements, right? Like extremely dogmatic and extremely looking at the edge cases and look at the bad sides of a language. But it's more like you have to choose, and it's obvious, but you have to use the right language for the right type of problem. And look if the transition from Java to Kotlin or Java to any language actually fits your business purpose. Because
and your team.
Doing it for the sense of doing it and getting on the hype train is probably not a good IAD. I mean, we can get that ball in with a hammer, no problem. But is it the right way? Right?
Yeah.
And I think, for instance, we have to make sure that you know your language. You know what the ups and downsides are, and you have to be very careful to implement something just because you saw on a conference, hey, this is cool, and now I found this example on Stack Overflow, which I copy-pasted, and it looks pretty nifty, but under the hood, you have no clue what happens. That counts for Java, that counts for Kotlin, and that counts for every library you use. So I want to conclude with know your language and know what the ups and downsides are, because you can use everything in a good and in a bad way. Anything to add from that?
I totally agree with you. And also discuss this with your teammates, because they have to be able to follow you with your mind, and they have to be able to learn the Kotlin idioms if you want to switch to it. It's not that easy.
I think that's a very good one, that you have to discuss it, first of all, with your teammates, but also with your company, if it's a good idea to connect to another language, because the continuity, to continue your project is something you need to be aware of. Because if you lose those 2 Kotlin developers that did all the heavy lifting, and you have a few juniors that need to take over, or somebody who doesn't know that, is there still enough stuff to grasp the idea, to maintain it, or to expand it, because we need to expand software? Or are we going back to the difficulties we had with Groovy and with Scala, that many people say, like, I don't understand this. Let's rewrite it in Java. And then we're back to square one. Yeah. So first of all, make sure that your team does it. If you do the transition, I would say, for instance, Paulien is very good at Kotlin. And if you say, okay, we want to do this and want to use Kotlin for that, let somebody else implement it. Yeah. Make sure that you share that knowledge. I think we will keep it at that because, well, it's a bit of a downer to say, yeah, it depends. But yeah, we are consultants. That's what we do. I'm working for Snyk, Paulien's working for Open Value, and I want to thank you for your attention. Thank you.
Thank you, guys.